So this week we will focus on another aspect of action physics in classical mechanics, which is the principle of stationary action. This is a general principle from which all classical mechanics can be derived, including Euler-Lagrange equations, as well as Newtonian mechanics. So after this introduction, you will have the possibility to do some revision of integrals in particular. Then we start with some math, where you will be introduced to the powerful tool of integration by parts, and also to the concept of stationarity, and we will first focus on the case of simple functions, and we will also talk about Taylor expansion. After this mathematical interlude, we will start the real physics of principle of stationary action. So we will need first to define what is a path. So this has a very specific definition in physics, and it's not just the usual concept we have in our everyday experience. We will then revisit a bit of mathematics in the case of stationarity, but now in the case of a functional. So a functional, you will see, is a function of a function and not just a function of a variable. Then we will show how we get Euler-Lagrange equations from this stationary principle. We'll then apply that to the case of free particles, and again there will be some transcripts. An important concept of action physics in general, which we could have done last week already because we only need Euler-Lagrange equation, is the concept of symmetries and conservation laws. You will see that simply by looking at basic properties of Euler-Lagrange equations, you will realize that if the Lagrangian, for instance, doesn't depend on some variable, we will call this variable a cyclic coordinate, and that will induce conservation laws associated to symmetries with respect to a change of this variable. So for instance, you will have invariance under translation in space will lead to conservation of momentum. Invariance under rotation will lead to conservation of angular momentum, etc. So this is a very powerful concept which is used again and again and again in physics, even to the construction of the standard model. Then we will, as usual, do a short review of what we have seen this week and look at some practice problems.